I'm waiting for Zoom to tell me it's okay for the YouTube sync. All right, okay, we are on. Welcome, Sara and Milan, for joining once again the DDDFR France meetup. Tonight it's kind of provocative title, and about aggregates. I will let you the stage right now. Thank you for making this talk with us tonight. I guess there will be questions, maybe for the audience. You want to have questions at the end, something like that, to answer at the end?
Yeah, yes. Let's at the end. Yeah.
Let's do that, so people, you can ask your questions, and we will answer them at the end. Please use the Q&A section instead of the chat. It will be easier for us to track and to, okay? Sara, Milan.
Thank you, Thomas. Thank you for hosting us. And thank you everybody for attending this presentation this evening. What we are going to talk about is the aggregate. The aggregate is that, long link, the aggregate. So my name is Sara Pellegrini.
And my name is Milan Savić.
We are software engineers, but today we are here in a completely different guise and a well-defined target. We are here to kill the aggregate. So the aggregate has always been one of the most controversial and weakest elements of DDD, in my opinion. Its definition is quite vague. An aggregate is a cluster of associated objects that we treat as a unit for the purpose of data changes. I'd like to conduct a survey. Please write in the chat or in the Q&A if you cannot use the chat. I would like to ask those who are watching what is their level of understanding of the aggregate. Who thinks this definition is easy to understand? Who, on the other hand, thinks that the definition is a bit cloudy, and who understood what it is only after years of experience? So from my personal experience, I can say that during my consultancy activity, I noticed that the full understanding of the aggregate concept remains difficult for many. It is easy to make modeling mistakes that will be very difficult to fix later. And as a result, a certain percentage of developers feel that the whole architecture is overcomplicated. So let's try to clarify.
Yeah, let's try to consult the blue book again. So what is written there? Cluster the entities and value objects into aggregates and define boundaries around each. Choose one entity to be the root of each aggregate and control all access to the objects inside the boundary throughout the root. Allow external objects to call reference to the root only. So already this sounds a little bit vague, right? It's not so clear to us what it means. Especially, it does not help us when we want to build an instinct when we are modeling our systems, when we want to be, how to say, more elegant in our solutions. So we are going to see some of the pitfalls of using aggregates. Since you already, I have guessed that you already have the idea that the theme of the presentation is going to be around the Kill Bill movie. So we chose 5 villains from the movie, and each one of them will represent one of the pitfalls of the aggregate approach. So ones for you who watched the movie, I guess that you're going to have a great experience, and others, I hope, to have a good enough experience as well.
So to better understand the criticalities of the aggregate, let's simulate a simple modeling exercise using event storming. The domain is the educational domain, and the rules are the following. A course cannot accept more than n students. The course capacity can change anytime to any positive integer different from the current one, even if the number of currently subscribed students is larger than the new value. In this case, the course will not be able to accept any new enrollments until a sufficient number of unsubscribes have taken place to ensure that the number of subscribers is once again below the capacity. So first of all, let's identify the events on our board. After the course has been created, it may happen that a student subscribes to a course or unsubscribe, and we know that the course capacity may be updated from time to time. Let's now move to analyze the trigger of these events. In our example, all these events are triggered by commands sent by the user. So far, so good. The process is natural and simple. One of the most powerful elements of DDD is that it has broken down the barriers between technicians and domain experts, thanks to tools capable of exploiting the immense potential of storytelling. First of all, event storming. And storytelling is an extremely effective technique because it is innate in human nature. It does not require any special competence or skill, and help us to break down the communication barrier between technicians and domain experts. In my experience, the fluidity of the discovery process that is amazing at the beginning. It's a snag when we try to introduce the aggregate into the story. Indeed, by definition, the aggregate represents the resolution of a technical aspect. The aggregate represents the boundary of strong consistency, the guardian of the invariant. When a change to any object with the aggregate boundary is committed, all invariants of the whole aggregate must be satisfied. In other words, the aggregate is the component responsible for ensuring strong consistency constraints within an ecosystem that is by nature eventually consistent. But at the same time, it tries to represent the business entity acting as a guardian of a set of business rules. It is complex to explain to business experts what it really represents. And obviously, we cannot provide business experts with a technical explanation of the aggregate. As a technician, anyway, whenever I try to design an aggregate, I tend to group all data that shares consistency constraints. In our example, the rules were all related to the course. That is why I would choose the course as an aggregate. But translating this idea into non-technical terms to explain it to business experts, it is not trivial. We can use metaphors by asking questions like this: who guarantees me that this rule will not be violated? Or in which package, in which box you put this information? Who do you address this command to? And these are techniques, tricks that can work, but they are not always effective. So this is the first bad guy in our story. The aggregate does not fit storytelling, does not fit with storytelling. So the introduction of the aggregate in the storytelling breaks the fluidity of the discovery process. It is an element that does not emerge naturally from the story. We technicians try to forcefully introduce it to satisfy our needs. The aggregate was created to respond to a technical requirement. Business experts should absolutely not worry about understanding the technical aspects of our architecture. Nevertheless, they are somehow asked to identify precisely these elements that are technical by definition. And furthermore, the aggregate brings our attention back to the model, away from the behavior.
And now we are in front of the second villain, and that is that aggregate mixes technical and business aspects. Usually in our minds, in our heads, we have a mental model of a business domain. And we also need to model our invariants, our business rules. That's what aggregates tell us to do, right? Sometimes those two match, sometimes they do not match, because, for example, we can have certain rules that span across several business concepts, right? And in those cases, we just try to fit it, and maybe it does not fit very well. One of the approach that is proven to be really good in practice is to try to monitor which data changes together and try to group them. And then once we are satisfied with our groups, then we try to give them names. However, it is not widely spread, not a lot of people are common with that, etc., etc. So it is not, how to say, widely used. Let's take a look at our example. So we have these events and commands, and usually we focus on nouns, on names, on entities, right? This is what we are used to do as developers. In our specific case, of course, we are going to select the course, and this is going to be our aggregate. This leads us to this landscape, right? We have a course aggregate. It has commands that it is able to handle, and it also has events that it is able to publish. Let's take a look now at the aggregate from the storage perspective. Let's say that this is state stored aggregate. We have aggregate root that is a course, and it contains a bunch of subscriptions. Now, when we need to take care of commands such as subscribe and unsubscribe student to and from course, we need to load the whole aggregate, and that's perfectly fine, right? We need to load all the data related to this aggregate. However, when we need to take care of the update course capacity command, we are only interested in the capacity, right? So we just want to know when the course is created and what is the current capacity, whether we are going to change the capacity or not. However, since the aggregate is a single unit of consistency, we need to load the whole thing, right? And we already see that this does not, it smells a little bit, right? From the other hand, if you take a look at the event-sourced aggregates, we have aggregate state stored as a series of events. So when course was created, capacity changed, student enrolled, student unsubscribed, etc., etc. For subscription and unsubscription to the course, we need to load the whole stream of events, and it makes sense. But again, handling the update course capacity command, in order to rebuild the current state of the aggregate, we need to load all events, while essentially we only need these two events, right? So already we see that something is a little bit off here.
Now let's add a new business rule. The course title can change anytime to any different title that is from any title different from the current one. So we need to introduce a new event that is the course has been renamed. Easy. And of course, a new command. So when we ask to the domain expert, who should this command be sent to? So the most obvious answer is to the course. The course aggregate is now responsible for something more than before. It may seem irrelevant, but this hides a pitfall. So let me introduce the third villain of our story. The larger the aggregate, the greater the contention. The natural attitude to identify aggregates in business concepts that are part of our mental model can lead to an expansion of the boundaries of the aggregate that sometimes is not necessary. Every time we identify a new event that pertains to a certain mental model, we tend to assign it to the respective aggregate. But it is paramount to keep in mind that the boundary of consistency is also the boundary of concurrency, and for this reason, the correct sizing of the aggregate can significantly affect application performance. If we decide absurdly to model our system as a single large aggregate, this would prevent any form of concurrent access. All operations should be performed sequentially as they relate to this single aggregate, which would act as a contention point. Suppose that the system receives concurrently two commands related to the same instance of the same course, the same instance of the course. The first requires the capacity of the course to be updated, and the second requires the curse to be renamed. Our instinct tells us immediately that these two operations will not conflict. They do not influence each other, right? Both commands are handled at the same time. That means that two replicas of the same aggregate instance are loaded. Each is updated based on the command being handled. And the problem arises when you try to persist the transaction. Since the aggregate guarantees internal consistency, it is not possible to accept two concurrent modifications. While the first of the two transactions will be accepted, the second will be rejected. It doesn't matter that within the aggregate, the two and the modified data are completely independent. It doesn't matter that the change in the title of the course will never affect the change in the capacity of the course, as well as the opposite. The fact that the two commands are managed by the same instance of the aggregate is sufficient to prevent them from being executed simultaneously. So assigning both of these commands to the same aggregate causes an increase in the contention that would not be necessary, as we know that the information they modify has no reciprocal implications. Nevertheless, they must be handled sequentially, since they are part of the same aggregate.
Now you may wonder whether we can mitigate this issue that Sara mentioned about the contention. And now let's try to propose an alternative solution to the one that we've just seen. So what we started with was a course with a bunch of subscriptions. So this was a single aggregate to try to meet all of our business rules. What we can do now is instead have two aggregates. We can have course subscriptions and course info. Course subscription aggregate is responsible for taking care of subscription, right? And course info is responsible of taking care of details about the course. Let's try to compare these two solutions. On the left-hand side, we have a single aggregate approach. On the right-hand side, we have two aggregate approach. With a single aggregate, we have more contention. Sara explained that pretty thoroughly. But it is simpler to manage, right? We have only a single instance, sorry, not single type of an aggregate, right? With the two aggregate approach, we have less contention. Why is that? Because we need to load only, let's say in this case, necessary data to meet our business requirements. However, we are adding more complexity because now our business rules involve several aggregates. There are connections, there are dependencies between those aggregates, and we need to take care of managing those dependencies. For example, what do we do when a course is deleted? We also, a course info is deleted. We also have to take care of the subscriptions, etc., etc. I guess that you get the point. All right. So at the beginning, we started with one aggregate. We went to production. We were persisting changes to that model to our storage, right? Then we decided to go on the path with two aggregates. So basically, we are changing our model. And now we need to decide what to do. So is it going to be easy for us to adapt to this or not? In a case where we are persisting our aggregates to the state storage mechanism, so I said it's a SQL database, doesn't matter. Refactoring the model can be simple as just writing a SQL script, for example, to update the structure in the database model, relationships, etc. Of course, in cases where we want to store our aggregates as serialized blobs, let's say, serialized JSON or XML or some binary format, this approach is not so sufficient. So in certain cases, it is easy, in certain cases, it is not that easy. However, when it comes to the event source aggregates, we are not quite sure, right? Because we want to change the history and we know that basically events are immutable. So let's take a look at the example, what we can do. Here in the event sourcing world, we have an event stream. It is stored in event store, and we have events that are already persisted that relate to a single aggregate named course. Now we want to take two aggregates approach. In this situation, we need to transform course created into two corresponding events. One is course subscription created, and the other one is course info created. Now they belong to two different aggregates. Then when we move on, we see that course renamed belongs to the course info aggregate, so we need to change the ownership, and the latter two belong to the course capacity, to the course subscriptions aggregate. We need to have an event store that can support this, right? And we know that basically premises of the event stores are such that this shouldn't be possible, right? So it is maybe not so trivial to be done. This gives us the fourth villain that we have in our world, at least in our presentation, and that is that the aggregates are hard to refactor. Not impossible, but hard.
So let's add a little more spice to our example, introducing another new rule. The student cannot join more than 10 courses. So back to the board. We need a new event for the creation of the student and the relative command, and so far so good. But here things get complicated, since I need a new event for the subscription and a new event for unsubscription, and both triggered by the respective commands. Deja vu? Yes, because we have already met very similar events and commands when we were talking about the course. But now I need two more, because the new rule that I have to be able to guarantee is relative to a new aggregate, the student aggregate. Why do I need two separate events that represent the same event in real life? The reason is technical. It is because they belong to two different aggregates. Here is our new student aggregate that is capable of handling some commands and emitting some events. Also, the student aggregate will contain the subscription that are necessary to make decisions regarding the following subscription and unsubscription requests. And this situation forces us to introduce a certain form of synchronization. The subscribe student to course request will be handled by a component that is able to deliver the respective commands to both the student and the course. The student and the course then publish their respective events. Very simple, unless one of the two aggregates refuses the command. For example, when the course is fully booked. In this case, the orchestrator components must react accordingly by sending a second command to the student to request the cancellation of the previous subscription. This is one possible solution. There might be several others. In any case, any form of synchronization requires additional complexity. And here you are, the fifth and final villain in our story. Transactions that span multiple aggregates could cause unnecessary complexity. The main aspect underlying the idea of the aggregate is the concept of boundary, the boundary of consistency, but also the boundary of complexity. Yes, because one of the purposes of the aggregate is precisely to contain this complexity, defining these small bubbles that are isolated from each other in order to have a minimal context where it is easy to make decisions. So this concept is perfectly in line with the best practices of decoupling and acquisition. The intention is great, but anyway, it implies a greater complexity whenever there is a constraint that spans more than one aggregate. You could answer, after all, it is nothing special. It is nothing more than a long transaction. Sure. It is a long transaction, and it is absolutely natural and common when it crosses the boundaries of bounded contexts. But I wonder how much it is actually necessary to introduce this complexity when the long transaction takes place within the same bounded context in the same software component. It is possible to avoid this complexity inside the same bounded context. We will see. Here they are, all negative elements of the aggregate. The aggregate does not fit the storytelling. It moves the focus from the behavior to the model. It mixes technical and business aspects. It can cause unnecessary contention and complexity. And in some cases, it is difficult to refactor. So we just need to shoot it down.
So the question that we ask ourselves is, do we want to shoot the aggregate down? Or let me rephrase that, is there a better way to implement the command model? So what are we going to start with here is to shift our focus and to put it more on the behavior rather than upfront modeling. Let's restart from storytelling. If we monitor what happens in our system, usually it is a bunch of actions, reactions, actions, reactions, etc., etc. The glue that ties these together are basically our decisions that we make. As one example of a decision maker, we can have a user, right? Here we have a lady, based on her previous experience and the information that she gathers from the system that she uses, she can decide to make a certain action, to do something within our system. Now, as a decision maker, we can also have a software component. Now, this software component, similarly to the lady, can gather information from the system that it needs to make the valid decision, to make the impact, right? And based on the information it needs, it can create the reaction to the required action asked by the lady to be done. So what we want to do here? So we want to move the focus to the decision. In this situation, decision block is the message handler, and this message handler, this decision block exists only in order to make the decision. And this handler solely knows what it needs to make this decision. It knows where and what data it needs to load in order to execute that specific command. This focusing on the decision together with event sourcing is going to help us a lot in achieving a little bit different approach to command modeling. So what is event sourcing? It provides a huge advantage because it decouples persistence from the model needed for taking the decision. And the message handler can build dynamically, basically on the fly, model needed for making the decision starting from the correct event stream. Let's try to exemplify. We have event stream. It is stored in event store. And here we have events related to the student and to the course. Now a command arrives. This command is to update the course capacity. With aggregate approach, we need to load the course aggregate, and we need to load all those events that were published by that specific aggregate. When we take a look at our decision maker, at our command handler, what it needs, it basically needs to make the decision on the following business rules. The course exists, and the new capacity is different from the previous one. So basically, why do we need to load this course renamed event? And in fact, we do not need it, right? You can just say, give me only events that I'm interested in. Let's load only those, and based on them, I can make the decision and maybe publish an event or not necessarily, right? This also requires us to adapt our event store APIs that we have. So what we would like to propose is that instead of loading stream of events based on the aggregate identifier, to load stream of the events based on a certain query that we call stream query. And I believe that we already had a question, what is stream query? So let me try to answer that one. So what is a stream query? It's something that we need to send to the event store in order to retrieve necessary events. How are we going to compose it? We need domain identifiers. So these are the concepts that we are interested in. In our use case, that's a course. It has a specific ID. So give me all events related to this course. But wait, we said that we want to select only the ones that we need, right? So we are going to scope even more the information that we need, and we are going to specify the event types. In this case, we only need course created and course capacity changed. And this is what we call a stream query. So the focus is on the message handler, and it gives us a lot of benefits. The first one is that we have less waste of resources. By loading less information, we are essentially going to need less CPU, less memory, bandwidth network is going to be saved, etc., etc. The other benefit is that we do not need to do any upfront modeling, right? The only thing that we need is just to load the right stuff. And this gives us a lot of flexibility, because now dynamically we can decide what information we need in order to recreate our model, and this model can adapt, right? So yeah, these are the benefits.
Let's see now what happens in case of concurrent write operations. Let's assume that the system receives two commands. One is the one to update the capacity of a course, and the other one is to update the title of the same course. And the commands are received at the very same time. So our instinct immediately tells us that there can be no conflict between these two operations, since they act on unrelated data. The two decision blocks can simultaneously load their respective event streams, they can rebuild their respective state models, and finally, they can publish their respective events. So far, so good, simple. But what happens if the system receives at the very same time the command to subscribe a student to a course and the command to update the course capacity of the same course? This time, the risk of collision exists. Both command handlers can simultaneously load the event streams to reconstruct their models. Suppose that the first block capable of publishing an event is the one related to the capacity update. Few milliseconds later, the other block publishes the subscription event. In this case, however, it could happen that the capacity update emitted just a few milliseconds before could invalidate the choice made regarding the subscription. In fact, the last course capacity change the event and not be considered when the first handler reconstructed its model. You can say that is not part of the stream. So how we can handle this situation? Here is the second idea we would like to propose. Next to the simple append operation, an event store should provide another operation, the conditional append. How does it work? It is very simple. Besides the events to be appended, the conditional append requests two additional parameters. One, the stream query that was used to rebuild the decision model needed for taking the decision, right? And the second, the ID of the last event that was used to rebuild that model. So what are these last two parameters needed for? They are used to verify that when I invoke the append, there is no new information that could affect my decision. In other words, they are used to verify that there are no new events matching that query that I used to make the decision, subsequent to the last one on which my decision was based. If the identifier of the last event returned by the query does not match the identifier received as a parameter of the append, it means that the decision made is potentially wrong, because it is based on out-of-date data. I may have decided to accept a student subscription when actually, just a moment before, the capacity of the curse has been reduced to the point of preventing that subscription. And in this case, the append is rejected as the condition is not satisfied. The decision block can decide to fail or to try again at this point by reloading the model, which will be necessarily more updated than before. So in practice, the conditional append represents the guarantee that an event or a group of events is published in the event store if and only if the event store does not contain any event that matches that query after the expected last event. So the conditional append represented the guarantee that the decision has been made on the basis of the most up-to-date data. Let's go back to the practical example. The first block to invoke the conditional append is the update course capacity command handler. Since the last event it loaded was number 592, the event store checks that at the time of the append, there are no events after 592 that would have been part of the query. Sorry. And since there is none, the append is accepted. But when the student subscribed to course command handler tries to publish its event, it also invoked the conditional append. It also loaded event number 592 as the last event. The event store now checks that at the time of the append, there is an event, the number 593 following the number 592, which is part of the query stream. And in this case, the event store rejects the append.
When it comes to contention, previously with aggregate approach, we had contention boundaries of the aggregate solve, right? But now the contention boundaries are of the stream query. By this, we are limiting contention, right? It comes naturally. Basically, less data needed to load, less contention is going to be as a result. But can we improve a little bit on this? I would say, let's try. As the result of our event storming phase, we had this, I would say, a little bit weird situation, right? Also artificial. We basically have duplicates of commands and events to the course and to the student aggregates, both for subscribing and unsubscribing concepts. If we take a look at the event stream in our event store, we can also spot these two duplicated events. When a business expert comes and see these streams and asks us, why do you need those? They're basically duplicates, but do you need two events representing the same fact that has happened in past? Of course, we know. The reasons for that is because we have two aggregates and we need to have two events to validate different invariants, right? But it is really difficult to explain to business people because the reasons for having duplicates here is basically purely technical. From the storytelling perspective, it is much easier, right? When student subscribes to the course, we have a decision, student is subscribed. When student unsubscribes, decision, student is unsubscribed. So there are no duplicates. Let's try to get rid of them to see whether it is even possible. So the first thing that we are going to try to do here is to try to get rid of the ownership. We have events that belong to certain aggregates. Let's try to get only the payloads of those events. We are going to call those events pure events. Then we are going, because we need to know to which domain concept these events belong, we are going to have another layer that we are going to call tags or domain identifier. These are basically links towards our event saying that this event belongs to this specific domain. Let's get rid of the owned event. And now we can see basically that we have pure events. Two of them are completely the same, but they relate to the different concepts. So why not just try and merge those together? So what we can do is to have a single event and having two domain concepts pointing to the same event. With this approach, we can get rid of the duplicates even more.
So this grants us another exceptional advantage. And let's find out what advantage by analyzing how our system now behaves in managing a command for subscribing a student to a course. The message handler knows exactly what data it needs to make a decision. It knows the invariants to verify in order to publish the student subscribed to course event. And now it can take advantage of the flexibility of a query to retrieve both student and course data in a single stream. The command handler is able to reconstruct the model necessary to evaluate in a single place, in a single moment, that the subscription does not violate the maximum number of students per course, nor the maximum number of course per student. If both rules are validated, it will be possible then to publish a single event related, however, to both business elements, the course and the student. Therefore, the event store should not only be able to append new events, but domain events. A domain event is nothing more than the pair formed by the pure event and a collection of domain identifiers matched to it. In my example, the domain identifier is expressed by a key-value pair, where the key represents the domain concept and the value represents the instance identifier. Actually, it is just an example. In fact, the domain identifier could be anything, as long as its value is unique within the bounded context. So the domain identifiers are matched to the single event. Two events published in the same transaction could be associated with different domain identifier. For example, if after a student is subscribed to course, the course reaches its maximum capacity, I may want to publish the course fully booked events in the same transaction. So the student subscribed to course event will be associated with both the student and the course, while the course fully booked event will be associated only with the course. So let's translate this example into pseudocode. There are two events to be appended: student subscribed to course event associated with the student and the course domain identifiers, course fully booked event associated only with the course domain identifier. The query is the same, is exactly the one that was made to reconstruct the model necessary to validate the command, to make the decision. A last event is the identifier of the last event used to rebuild that model. If the query at the time of the append returns a last event different from the expected one, then it means that the decision was made on the basis of an incomplete model, and in that case, the append would be rejected.
Let's try now to exploit these pure events even more. Let's see what attributes they have, and later on what benefits we can extract from them. So basically, pure events do not belong to an aggregate, so there is no ownership of them. Pure events are just descriptions of fact that something relevant, something important has happened in our domain, and they can be related to one or multiple domain concepts. The very first benefit that we have is less complexity, right? So there is no owner of the event. The business decision now can easily involve several domain concepts. So Sara mentioned that orchestration between different aggregates. In this situation, this is not needed. Why? Because the decision can be taken in one place. So we can basically forget about this synchronization mechanism. Almost in a situation when our decision is so not our decision, but our orchestration is spanned across several bounded contexts, then we need some form of synchronization. We cannot put the decision of two contexts into one handler. It makes no sense. The other benefit that we have is more flexibility, right? Because event sourcing decouples the persistence from the model. right? We only need to, when we want to refactor our model, what we need to change is that stream query. So we change it, we add or remove domain identifiers, add or remove event types. So we are able to dynamically reconstruct our model. So when our model evolves, or maybe we made a mistake in our model, it is much easier now to refactor because we don't need to change basically almost nothing in the storage mechanism, but rather in the decision maker, the handler itself.
So the aggregate is finally dead, together with the negative aspects associated with it. So this new approach that we decided to call dynamic consistency boundary has several benefits. It integrates naturally into storytelling. It focuses on behavior instead of model. It reduces the contention and the complexity, and it simplifies the refactoring. So the aggregate is dead, but be careful. This does not mean you need to organize the system with hundreds of completely unrelated command handlers. Absolutely not. So clustering commands into logical groups and delegating their execution to the same model is and remains a correct programming approach. The difference lies in the fact that before, by the very definition of aggregate, these models necessarily had to be isolated from each other. Killing the aggregate means admitting the possibility of contamination between these models without renouncing consistency. So a less dogmatic approach, which in any case must not disregard good programming practices, but which, thanks to greater flexibility, allows the best design to emerge over time. And the ability to create this intersection between models does not necessarily have to be exploited in every situation. There will be thousands of cases where this is not necessary. So as always, there is no a single answer or a single truth. Choices must always be made with pragmatism and common sense. Thank you. So now we can look at the question.
Yep. So if you want, Sara, I can go through the questions. I can, or maybe Thomas, you want to say something before?
No, go ahead, Milan. Perfect.
All right. So let's see. Anders asked about the string query. We talked about that, but let's see whether it's clear. Maybe Anders, you can ask another question. I see a question from Clement, and I already read it because I finished my part, so I was really curious. So let me read it out. I think it's a really good question. So Clement said, you say business does not care about boundary consistency, but then it is open door to I want everything consistent all the time in all over the world. Don't you think that talking about boundary consistency is useful to talk about eventual consistency that exists in all systems, but too much avoided with database-driven design and transactions? So I think that basically, if you ask your business, do you want this to be consistent? They will always say yes, and they want everything to be immediately consistent, right? And this is really dangerous. So we are not proposing that you should just lock the whole event store, the whole stream of events in order to have your consistency implemented, right? So it is a knife, the tool that we are giving you as an idea, right? And you should use it with as Sara said, with what's the slide, with common sense, right? I think
this one.
Yeah, there is no pattern that can replace common sense. Of course, you can lock up the whole event stream, but probably it makes no sense.
May I ask just one thing? Wouldn't be an obsession of the technical people instead of business people? I most often see developers saying that everything should be immediately consistent without even having the discussion with the business.
Yes.
And Jérémy Chassin once told me that in the hospitality world, we as developers, we are very keen to try to find a way to prevent having contentions and And yes, two reservation of the ultimate room for the last hotel of the town, and he was saying, but maybe it's not a problem we need to solve. Maybe it's a domain concern, and we should ask the business. And the business very often will tell us, no, accept the two of us, and then after we can arbitrate, and let's pick only the one that has a fidelity, a membership, or will stay more longer in the hotel or whatever. And very often I see that we are tech people, we are trying to find tech solution for that without having a discussion with the business, more than the business asking us such impossible stuff.
To be honest, I totally agree with you, Thomas. It is my experience as well. I believe this is a lot more a problem in the mind of developers that are somehow used to believe that can exist the full consistency. But people that are not technical are more inclined to accept the eventual consistency as a fact, as just a thing that exists right in the world. So it's more us that are trying to believe that it's possible still, even if there are proof that is not possible to live in a completely consistent world. And of course, I believe that this is not a question that we should ask to the business expert, in my opinion. We should never try to bring the transactionality and the consistency as a problem to them, just trying to understand their point of view from the business perspective. And I believe that in many cases, what Thomas described is just what happens. So they can accept easily the fact that there are situations like this.
All right, so the next question is from Anders, another follow-up question for end of talk regarding stream query. What's your ideas for how to get the stream query to work with a relational database such as PostgreSQL? Do we need the domain identifiers, or could we filter on the JSON event data? Do you, Sara, want to answer?
Oh, yes. So it depends in the sense that it is probably also possible, right, to implement something that scan all your event store and go inside the payload and with a JSON query, just find if your event matches a determined query. It is possible, but so Milan and I are working in Axonic, that is a company that is building products for event-driven application. And one of these products is an event store. And it is easily, you can find a lot of cases where event store reach terabyte of data. And it is just impossible to think that performant query can go inside the payload and do a JSON query or an XML query to find information inside. So it can work in certain situation when you have just few events and when the situation probably is not yet in production. But when you go in production, having this domain identifier, this tag that are performant is paramount to provide a very performant query. So it does make no sense if it is slow and if it takes a lot of time, because this is needed to rebuild on the fly the model you need to make a decision. So it must be super performant.
Yeah, so I think the performance is really important here. And so basically, if you have a proper event store, you would have a possibility to create a custom indices or something like that that will give you performance that you need. In PostgreSQL, if you're trying to access and deserialize the blob, that's going to be probably expensive. So I'm not sure how performant that would be. So
it really depends from how many events you have. So if you have few, maybe it is good, but at a certain point, it will not scale anymore.
Yeah, maybe there could be an intermediate approach just to extract domain identifiers in columns and put indices on them and maybe that could speed up the thing. I'm just thinking out loud. I don't know. All right. Next question by Clement. We have Clement and Anders competing for questions. And, why do you bind aggregate notion to a noun, database-driven entities? It seems to be a big mistake to me. And why do you say it is more complex and more coupled with two aggregates? Indeed, the idea of splitting into aggregates was to decouple thing not coupled, and I would prefer two simple things than one complex thing.
Let's start with the first one that is very simple, because probably it was not clear in the presentation, but we do not believe that finding the notion. The question just disappeared for me for some reason.
For me as well.
Sorry, I think I made a mistake. You can see that on the answer the tab.
Okay.
Sorry for that.
Okay, no problem. So I believe that where is it here? Okay.
Last one.
Yeah, that the noun is not what we want, right? It is the practice that is very commonly used, but it is not what we are suggesting. It was just an explanation of one of the pitfalls of the aggregate. People tend to, because it is difficult to find the right boundaries, the right aggregate, people just tend to search for nouns. That is what happened, not what we are suggesting.
Yeah, and the second question, why do we think it's more complex? Funny thing is that today Sara and I were preparing a little bit for the presentation, and we were wondering what questions could arise, and this was one of the questions. So we are super prepared for this one. So basically, the complexity comes, for example, we say that aggregates are unit of consistency, right? If you want to manage transaction that spans across them, you need some mechanism for coordination. One of the use cases that is going to be more difficult to manage is what happens when we delete course info, right? When we delete course info, we also need to go and delete our course subscriptions, but we do not have consistency boundary there, right? So we need to manage that, I would say, business transaction, if I may call it like that, and take care of deleting all those subscriptions. So basically, this is one of the examples that comes to my mind.
So basically, there are these mechanisms to, in a way, synchronize the life cycle of these instances, because they need to live and to die together.
Yeah. All right, question from Anders for later too. Isn't the pure event approach making versioning harder, and not to ensure read models are built with events in the right order? Any pitfalls to be aware? I'm not sure it's connected, because you can version pure events. So the ownership has nothing to do with versioning. So versioning would stay the same.
Yeah.
So I don't see.
The payload of the event. So basically, what we are proposing with the pure event is to detach an event from the aggregate it belongs, right? So now the event is just an event. It can be associated to business concept, but the versioning of the event, of the payload of the event, remains exactly the same, doesn't change. And to ensure that the RIS model are built in events in the right order, same as before.
So events must be in the order, otherwise it's really difficult. Although I'm really trying to make a case where you don't have to have events in the exactly the same order on all event store nodes, but that's something else. Oh, something else.
But yeah, in this regard, that doesn't really change anything in the regards of the ordering of the events and the versioning of the events. It is exactly the same as before.
Yeah, everything stays the same. Okay. Clement, nota bene, agree on refactoring and fragile to business changes. That's true. Okay, we can just answer this one. Yvonne, another benefit is that the chance that commands fail because of concurrency is smaller. That's true. I believe that we explained it. Maybe we didn't explain it very, but good one, Yvonne.
Absolutely. Of course, the contention now is not on the aggregate that can be larger, but on the stream itself. So it is smaller, the chance to have a collision.
All right, so Clement, with string query and independent message handler, isn't it more complex to identify what is impacted by a new event business changes?
True. I believe it is true. So let's say that the aggregate create a place, right, where everything is there and you can immediately check. But as we wrote in the last slide, this does not matter that you should detach, right, all command handlers. If there are command handlers that make sense to put together and to have everything in the same area, in the same component, it's still a valid option, and it should be like that, I believe. So there are many cases where it must be kept in this way, so you can immediately notice if there are something that can influence other command handler in a way, right? The point here is not to break this good practice. The point here is just to give you a more flexible approach, that in the specific case when you need it, you can be flexible, you can evolve your model easily. You can decide to make a decision based on 2 or more business concepts. So that is not trying to kill the aggregate in the sense of good practices of high cohesion and decoupling. This is not.
I really like the slide that is currently on. It makes a lot of sense.
In this regards, yes.
Yeah. So I'm not French, so I'm not going to pronounce the name. Is Guillaume? Huh? Is that correct?
Guillaume.
Guillaume. Oh, thank you.
Exactly.
So that's very interesting. In a way, it's quite similar to the last updated timestamp that can exist on entities aggregates to prevent concurrent modifications, but applied to events. Can be smart. Did you try it in production? What are your feedbacks of using it in real life? Do you have a repo with code? So this is still in a phase, I would say, of cooking. So we're still brainstorming a lot, and we are going to try in FXonic now with the company that we are working for to build something like this. So currently it is still in, I would say, prototype phase. Yeah. So when we have something to share, we would definitely like to do so.
Yeah, but I'm sure that we will pretty soon share some repo. We are doing some experiments. And it is not easy still using production, but it is a good way to understand better what is the idea behind it.
Yeah, and I think firstly we wanted to expose the idea to the world, to gather feedback, and that's why we are here, right?
Yeah.
To get more understanding how people react. Yes, absolutely.
Questions, feedback, and stuff like that. I've seen that you've managed some session before that. What were the feedback so far?
Very good. Yeah.
Yeah.
Yeah. So I did only one session in Italian. Received a lot of good feedback, and people are trying and doing experiments like we are. So far is very good, the feedback. Yeah.
Okay, cool.
Right.
I must admit that the possibility of contamination or intersection across models is very interesting and thought-provoking. The kind of thing you need to think a little bit about, to play with.
Exactly.
Yeah. Very thought-provoking.
But there are some blogs on this topic, so you can definitely read as well.
Yeah. Maybe I can share the blog somewhere if it's valuable.
In the chat, yeah.
Yeah.
So are you comfortable with putting too much domain logic in the command message handlers? Too much responsibility on handlers, in my honest opinion. Too much responsibility on handlers. Handlers should stay rather generic in my opinion, they should just route events to concerned entities aggregates. Of course, you put less complexity, but the risk is to add more coupling.
To be honest, I don't see this risk. On the opposite, I see this as a very single responsibility. So the handler exists with the only responsibility of handling one trigger. That is, its unique only responsibility. And it can, of course, load a model that is built for the purpose of validating one invariant. So it is not, I'm not saying that the command handler should not forward the validation of some invariants to a model. But I'm saying that the single responsibility of the model, of the handler, is exactly to make this decision. And it does that, retrieving the models that can help in order to validate invariants. So
yeah, I would also like to add to this is basically, if you try to spread, so you have a single business rule, if you try to spread it across the code, I think that it would also convolute, and you're not going to have, as Sara mentioned, single responsibility, right? It is a single rule, it should be in a single place. And we saw some of the approaches with orchestration that can basically span, in aggregate and in Saga, then in aggregate, and then it's getting more complex to understand what's the rule about. Okay. Next question. If you think about why aggregate was introduced without event storming in mind in Blue Book, I would say it was because code bases were a nightmare with lots of transaction scripts picking in any tables they wanted. Don't you think it is the same thing here to pick just the events we want for a decision?
So I believe that the answer is the same as before. So the point was not, absolutely not, to go against this idea of boundary, right? That is behind the aggregate. So the idea of containing complexity is something we believe in. So the idea of I cohesion and decoupling is something we believed in. So the point is not to go against this idea. It's not to create crazy query that that can I don't know, takes months to be executed. The point is just to, in 90% of cases, I believe that in production the query will be belonging only to one concept. But there are some situations where it could be useful to have multiple concepts. And there are some situations where we do not need to read the full stream of events because we just need one information. Like, for example, if we decide to have one aggregate with all course information and subscription, we don't need to have information about other things that are not belonging to the course capacity whenever we want to change the course capacity. So it is an approach that is can be lighter and can reduce the contention, and that is basically exactly the same that happens right now if you use even sourced aggregate, but limiting basically the stream scope.
Yeah, I just want to say one thing that we didn't mention, maybe it's obvious, maybe it's not, that basically this approach is fully compatible with aggregate approach. So if you say that your domain identifier is aggregate identifier, so you have only one basically domain identifier, you still, I mean, you have the flexibility of this approach, and you can still use aggregate approach. So you can choose maybe in certain cases what suits you better. So the point is to give you more flexibility in cases where you need it. In cases where you need it.
And for sure, the boundary of aggregate is one of the main challenges that we often have to face. And very often, I think that we as dev, we draw our first mental model with the read model in our head. And very often we involve, or we get too many information that are not requested to take decision. And of course, this is one of the first difficulties you face when you start using aggregate. So you may success. at the end, but it's really yeah, an important question and challenging question.
This, Thomas, is a very good point, because one of the main reasons, let us think about this, was to let the model to evolve easily. Because sometimes you really need to make decision in a very early stage, and that is the moment where you have less information, and you regret this decision later, right? So in this way, it allows you to be a little bit less dogmatic and a little bit more flexible.
Absolutely.
Okay, Yvonne asked the question about the examples. We already answered that one.
Yep.
Event sourcing and not event storing. In your last question, Clement. Okay, we answered that one. What are the alternatives from event sourcing to tackle aggregate complexity? I'm not sure that I understand this question.
Me neither. Maybe, Imad, can you
Can you elaborate more on this one? I'm just going to mark it as done. Okay. Are there any code projects on GitHub that can be used as a reference? So nothing from our side to share. Yes.
Yeah, but as soon as we have something, we will share as a comment to this recording, if Thomas, if it is possible.
Yeah, absolutely. And maybe the question from Imad was a little bit related to something like your solution is tight and related to event sourcing because
Yes.
you are working for that. So I think, I guess the question was much more for people that are not doing event sourcing yet, or is there alternative to aggregates in a non-event sourcing
So this solution, as you have seen, is pretty dependent, right, from event sourcing, because event sourcing provides you this huge advantage of decoupling the persistence from the model. From the events, you can rebuild any kind of model you want on the fly. So that is exactly the point that gave us this benefit, and everything is based on that for now. So if during the evolution of this approach, we will have some idea also for state persisted aggregate, of course we can, we will share, but for now it is specific for system that.
Maybe one attempt, if it was the kind of questions, there is something I've seen that lots of people conflating domain-driven design with CQRS or event sourcing struggles to distinguish aggregates with entities. And very often they directly think about aggregates, whereas in most of time they are dealing with entities. One can say that it's not really important. It should be a DDD people debate, but it may have design consequences because and design impact, since the rule says that one aggregate should not include other aggregates, etc. It's closed some door in the design, in the mindset of the people, and you can end up with a situation I've seen once. Something like you want to digest, let's say, banking transactions, and people were saying, okay, banking transaction is an aggregate, for the reason I've just mentioned. Let's say everything that we manipulate is an aggregate by default, something like that, in their mental model. Once they pick that decisions, when they want to make an import of massive banking transactions, they are kind of paralyzed because they are saying, I'm not supposed to compose many aggregates from within an aggregate that would be the, let's say, the import, the banking transaction import aggregate. So they are ending with endless, I would say, transaction, eventual consistency among thousands and hundreds of thousands small banking transactions, raising events, being handled, etc., etc. Instead of having just one thing that is, I want to import 200,000 transactions. This is my aggregates, and that's it. And I'm allowed to manipulate banking transaction because there are entities and not aggregate themselves. So maybe in some situation I've seen, considering the things that this is an aggregate and this is not actually, will remove some.
Yes,
We will provide more answers and more design alternative.
absolutely, absolutely. I totally agree. And the point is that, in a way, this rule force you to feel, right, this friction and to be forced to define these bubbles that are completely detached from others, right? And in a way, this is good because it forces you to contain the complexity. It forces you to think about the fact that your system cannot be completely consistent and to decide where this boundary is. And this approach does not mean that we don't want to have a boundary. We want to have a boundary yet, but this means that in all the situations where there are these complex use cases, you can be more flexible and you are not stuck. You can but that is very important to say that the concept behind the aggregate, the good practices that are behind the idea of aggregate are not bad. We truly believe in them, but sometimes it's just too much strict. And this is an alternative that allows you to be strict when you need and to be more flexible when there is the needs to be.
There's the room for other solutions to that
Exactly.
challenge. Okay. Interesting. Do we have seen all the questions, or do we have?
We have others, I believe. We have.
Yeah,
Do you have still some time, Milan and Sarah? It's okay for you?
Yeah,
okay.
sure. Let's complete it.
Cool.
So Christopher asks, when you speak of order, do you mean global ordering of all events, or is there a concept of events whose order relative to each other is not important? So basically, in the event store, in the event sourcing world, we are talking about the global order. So each and every event has its own global sequence, and everything is fully ordered.
Yeah.
So yeah, that would be the answer. Although I would like really to explore the idea of what you are saying, Christopher. But yeah, it's something that I have in my mind to see whether it would be possible and whether you can achieve everything that you need with the relative order of events. So basically to have a mixed order on different nodes in your event store. Okay. Does this solution require global events versioning? So when it comes to versioning, it stays the same as it was before, right? So nothing in regard to versioning has
Nothing
changed.
changed. Yeah.
From Damir, the whole idea reminds me a lot of the advice given by Von Vernon approximately 10 years ago about designing small aggregates. In addition to those advice supported by your approach, you also effectively resolve the synchronization problem between aggregates. Very nice. Thank you, Damir.
Thank you, Damir.
Christopher says this approach makes aggregates dynamic rather than static, and that's very, very true. And when you say aggregates, I really like the quotes.
Yeah, it is not aggregate anymore because they can, they potentially, even if maybe in 90% of cases they will not, they potentially have interaction, right, of the events. Yeah.
So that's it.
Okay. Once again, thank you very much. I think it was really thought-provoking. I guess you will probably have more questions in the upcoming days from the community, from the audience.
But let me show once more our Twitter account.
Absolutely.
So if you have any question, you can write to us directly.
Yeah, write to us.
Absolutely. We'll put that on our Slack also, for the DDD France Slack, and yeah, for people to contact you if they have more questions. Thank you very much. Sara,
Thank you,
Milan.
Thomas, for hosting us once more.
It was my pleasure. Our pleasure, I guess. See you, and let's stay in touch with the community. We will have more events in the upcoming weeks, I would say, but to be announced soon. Have a nice evening. Cheers.
Bye-bye.
Bye-bye.
Bye. So I need to cut live. And I think this is it. I need to run to say hi to my children.
Yes, yes.
But
Thank you, Thomas. Again.
no, once again, it was really a pleasure to host you, to have you, and really, I'm really thrilled by what you have shown us tonight. So.
So I really believe that this can really revolutionize in a way.
Yeah.
And
Something
because,
like that. Absolutely.
yeah.
So talk to you soon with more
Talk to you
questions
soon.
and